Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video we are going to formalize the equation for the optimization of the support vector machines. If you remember guys, in the last video we have talked about the assertions that we are making, the support vector assertions that we are making upon our support vector machine SVM, right? Now guys, we are going to continue those calculations that we were doing the last video. So if you remember guys, we were doing somewhere around this calculation, like we have done the y sub I multiplied by the whole equation, and that is x sub I into w plus b. Okay, right? Now guys, here we don't have, okay, so we have the bars on the x and we don't have the bars, so I'm going to add the bars for the same thing. Okay, now so we were left off with the same calculation where we have the y sub I into x sub I, and you have this dot in the red color that you are seeing is a multiplication here right now. We are multiplying this, and then w plus b. So guys, here we know the value of b, and then we know the value. So guys, if you remember in the last video we were having two equations where we were having y, if the value of y sub I is -1, then it's going to be equal to -1. Okay, so we have to multiply this y sub I with the whole thing, right? So for multiplying this, we have multiplied this on the other, we have to multiply those things on the two sides, right? So guys, at that time the value of minus y sub I is -1, right? So we have multiplied minus into minus, and we got the +1 here, and for the same thing for the plus class, right? After that, what we thought is we thought of moving this +1 to here, and then we got combined two equations into one equation, and then we got it to -1, right? Now guys, we have the equation is y sub I x into x sub I into w plus b -1, which is equal to 0. Now guys, if it's equal to 0, then we can, as I said you, it's going to be on the decision mountain. Now guys, we are going to begin talking about how we go about the formal optimization of the problem of the support vector machine, right? So guys, in this video specifically, we know that how we acquire the best values for the vector. We are going to search for the how do we acquire the best values for the w and the b. So guys, we don't know the value of w and b at the time, remember? And then guys, in this video I'm also covering some of the other fundamentals of the support vector machine. So okay, so guys, to start this, I'm going to recall the formula of the hyperplane, and that is w into x plus b. Okay, and thus guys, we have asserted that the definition for the support vectors in the equation will be 1 for the positive class and for the -1 for the negative class. Guys, we can also summarize that once we find w and we satisfied the constraints problem, that the vector w with the smallest magnitude with the largest b, right? And our decision function for classification of unknown points would just simply ask for the value of x sub I plus x sub I into w plus b, right? Now guys, for finding this value, what if you have the value of 0.98? So guys, how it would look like on a graph. So guys, let's see here. It's going to look something like this on the graph. It's going to come. Okay, so guys, we have a x2. Okay, we have a margin where we have the x2, and then we have the x1 and x2. Okay, right? As I said you, how it's going to look. What if the value is 0.98? Then what it might like on the graph, right? So guys, this is how it's going to look like on the graph if we give the value of 0.98. So now guys, here we have a question that, are we beyond the decision boundary here right now? So guys, we have done this. So if we give the value of 0.98, then we have another question, and that is, are we beyond the decision boundary, right? Yes. So guys, we are beyond the decision boundary, which is where we have the what I say. Okay. So if you remember in the last video, we have talked about if the x into w plus b equals to 0, then it's going to be on the decision boundary, right? Then if it's going to be less than or equal to 0, then it's going to be minus class, and if it's going to be the plus class, then if it's the plus class. Okay, so anyhow guys, now guys, just the actual decision function for an unknown feature set is simply assigned, and that is x into b x into w plus b. Now guys, that's it, the question here. Now guys, if it is a positive, then it's going to be the plus class. But guys, what about the negative class, minus class? Now guys, now in order to get that function, we need w and b. So guys, already we have assigned that. If you remember in the last video, we have the constraint function which is y sub I, the xi into w plus b, if it is less than or greater than or equal to 1, then which requires us to satisfy our feature set. So guys, if you don't watch the last video, then watch that video, because these two videos are just linked. Okay, so for understanding this video, you have to watch the previous video, and that is the support vector assertions. Okay, now guys, how come we are requiring known feature sets to greater than or equal to 1? Now guys, without doing the multiplication by y sub I, where is it? Okay, so we have the y sub I into without doing the multiplication with the y sub I. So here we have the plus b. Okay, let's give it something like this. Okay, now we got the plus b. Now guys, without doing the multiplication with the by this y sub I, then this is basically requiring all of our own feature sets, right? So to pass it, right? So if passed through x into w plus b, if it's passed, then it should be greater than or less than minus 1, right? So guys, despite us having just shown the data, the value, say we have the 0.9, as I said it before, would be a positive class, obviously. So guys, the reason is that unknown data to be classified can be between the support vector hyperplanes and their decision boundary. Okay, but the training data cannot be classified. So that's the reason that we cannot. Now, so guys, our goal is to minimize the vector w and maximize the b. Okay, and then with the constraint such that y sub I into x sub I plus into w plus b, where greater than or equal to 0. Okay, greater than or equal to 1. Okay, it should be maximize something like this. But guys, here we have if you see here, we have a confusing point here at this point. Okay, and that is, it's important not to confuse what we are trying to satisfy the constraint with the vector w, but minimize not the vector w. Okay, we are not minimizing the vector w, but the magnitude of vector w we are minimizing it. So guys, there are many ways to perform the constraint optimization, but the first method I am going to run through is the traditional definition of the support vector machine. So guys, to begin with that, consider we fundamentally are trying to maximize the width between the separating hyperlines. Okay, so guys, as you can see here, the previous graph that we have shown you. Okay, so guys, that we are doing is we are trying to maximize the width between the separating the hyperplane lines. Guys, the width between the vectors can be denoted as the width equals to x sub plus and then minus x sub minus into, we are going to multiply that with the vector w by the vector. So guys, as I said, this is how it's going to be denoted, right? So anyway guys, that's all for this video. I will be continuing this part in the next video. Okay, so anyway guys, that's all for this video. I hope you liked this video, enjoyed watching this video, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye.